Good morning, everybody. Happy Thursday. Jumping into our next lesson of solving systems of equations. And this is where we're going to learn our third and final method. And this one's called elimination. So far we know graphically, substitution from yesterday, and this will be the third piece of the puzzle, which is elimination. So with that said, let's jump in. Page 633, we're looking at solving by elimination, which is our newest method. And remembering we can always solve with our graphing calculator. Rearrange both to y equals and graph it, find the point of intersection. We can always solve with substitution, which is, rearrange one, isolating a variable, and then substitute it into the other equation, go from there. And then now this method, which is elimination. So I'll kind of read through it. But again, it's probably not going to make much sense until I actually do a couple examples. So step one. If necessary, multiply each equation by a constant to obtain coefficients for x and y that are identical, except perhaps for the sign. Okay, so I'm multiplying equations. I want coefficients to be the same. That's going to be important. We'll think more about that later. Add or subtract the two equations to eliminate one of the variables. Oh, eliminate. The name is elimination. Okay. Solve the resulting equation to determine the value of one of the variables. Got it. Substitute the solution into either of the original equations to determine the value of the other variable. All right, that's a lot of words. Let's actually do an example. Okay, consider these two equations. I have 2x plus 7y equals 13. Let's call that equation 1. 3x minus 7y equals 2. That's equation 2. First thing to notice, I have my x, my y equals a constant. X, y equals a constant, and they're stacked up on top of each other exactly like that, exactly lined up. That's important, okay? Something to consider, something to know, I am allowed to add equations or subtract equations. So if I look at this setup right now, what I want to do is add these equations, and that's what it tells me to do, and that's what I'm going to look at. Well, adding would be, this is why I stack them up. I can add the x's, I can add the y's, and I can add the constants. Now, why I'm doing this and why I'm going to eliminate it is I look at it, and this is a beautifully set up equation where you have 7y and then negative 7y. So if I added those together, I would get 0y, or I would get no y's, or I have eliminated my y's. Okay, so the point of elimination is to find some way that you can add or subtract equations to eliminate one of the variables. Okay, it says add or subtract. I typically look for a way to add the equations together. That way I'm consistent, but technically you could subtract as well. Okay, so 2x plus 3x is 5x. Negative 7y minus 7y. You could say plus 0y. But normally I wouldn't even write that. I'll just write the next step. And then don't forget about the constants. 13 plus 2 is 15. So really, the equation I have is 5x equals 15. That is the process of adding these equations. That's what it told me to do here. Okay. Now, it says use the equation to determine the value of x. Hey, I can solve this. Divide by 5. Divide by 5. That's a single variable. It's a really quick solve. 15 divided by 5 is 3. Awesome. Well, there's one of my pieces. I know when I solve a system, I need the x and I need the y. And I happen to find it pretty easily. Okay. Here's where elimination is a little bit tougher than substitution, and it's not quite as nice. Substitution, as soon as I found one of the variables, I just went right to an equation where it said, hey, y equals this, right? I found x, y equals this. Neither of my equations are solved for y equals, okay? Neither of my equations are solved for y equals. So I don't have an easy route. But the thing is, I know the value of x. So if I plug the value of x in here, I could solve for y. Or if I go to equation 1 and plug x in here, I could solve for y. It doesn't matter. I have two equations that need to satisfy the x and y, so I could plug into either. So I don't know, for simplicity's sake, let's just do equation 1. Okay, the first one. Normally I try to pick the equation with the smallest numbers or the least complicated. Well, they're both pretty much the same. So 2 times 3 plus 7y equals 13, or 6 plus 7y equals 13. And I have to solve for y. I have to do a little bit of rearranging. Not the worst thing in the world, not the hardest thing we've ever solved. But it's just a bit of work. It's not quite as easy as substitution. But at the end of the day, after that solve, I get a value of y is equal to 1. Okay, so, hey, I have my x and I have my y. We'll verify in a sec. All right. The idea of elimination was I got my equations stacked up, and you're saying, could I just add or subtract them so that I eliminate one of the variables? And then once I do that, I solve and plug in for the next one. Okay, verifying. Let's just verify. I'm not sure if we'll verify all of them, but we'll do this one. I'm going to take 2x plus 7y equals 13. I'm going to verify that. And I need to verify that my x and y work for the other equation. I need to verify both. Okay, so the first one, 2 times your x value of 3 plus 7 times your x value of 1, supposed to equal 13. 13, that's fully simplified. I don't need to continue simplifying that down. On the other side, 2 times 3 is 6, 7 times 1 is 1. Oh yeah, 13. This simplified to 13. On the other side, it simplifies to 13. Left side equals right side. So that's good. But that doesn't mean my answer is correct. All that means is it worked for that equation. I also need to verify it in the other equation. 3 times 3 minus 7 times 1 is supposed to equal 2. And I actually don't need to keep writing down the 2 because it's already simplified. 3 times 3 is 9 minus 7. Oh yeah, 2 does equal 2. Right side equals left side. You need to write this little statement at the bottom. Left side is equal to right side, which is the 2 is equal to 2. So it's good. Okay. So there you go. Solving by elimination. All right. Let's do another example. Consider the system of equations. 2x plus 6y equals 6. 2x plus 3y equals 4.5. This one, it's already stacked up on top of each other. That's really nice. I'm looking to do elimination. And I look at the y's this time. Well, no. 6y and 3y, those have different coefficients. 2x and 2x, hey, my x's have the same coefficient, okay? So I'm already on the right track. I'm seeing ways that I could eliminate them. The last example, it was the same coefficient, but opposite signs. So when you add them together, they disappear. Well, this one, it's the same coefficient, but the same sign. So here's the second option, and I don't do this a lot, and I'll show you how we can work around it later. But I can also subtract equations, okay? So 2x minus 2x, 0x. And normally I wouldn't write the 0x, but we'll do it just for explanation. 6y minus 3y is plus 3y equals 6 minus 4.5 is 1.5. So instead of adding the equations in order to eliminate something, I subtracted the equations, okay? Well, really this is 3y equals 1.5, y equals, little solve, okay? This is the nice part about elimination is once you've done the add or subtract part, it's a really quick solve, okay? 1.5 divided by 3 is 0.5 or 1/2. If I wanted to write it as a decimal, maybe I could have written it as a decimal. Okay. All right. Well, now that I have this, I can go back and plug it into one of the equations, okay, to find the x value. So doesn't matter. I could plug it into here and solve for x, or I could plug it in up in equation 1 and solve for x. Doesn't matter which one you pick. I am going to pick equation 1 again because equation 1 doesn't have a decimal. It's all whole numbers. Equation 2, I have to deal with a decimal. I don't really want to do that. Okay, so I'm going to take that into equation 1, and I'm going to say, so 2x plus 6y equals 6. Well, 2x plus 6 times 0.5 equals 6. You plug in the known y value, and now it's an algebra problem. 2x plus 6 times 0.5 would be 3 equals 6. Start solving algebraically. 2x equals 3. Divide by 2, divide by 2. It's a fraction. Because I've already written it as a decimal, maybe let's just write it as a decimal. X equals 1.5. Okay, or 3/2. All right, there you go. So that is solving by elimination, but when I stacked up my equations, I actually subtracted them this time. Okay, it says to verify. Let's not verify. You can verify on your own. Yeah, let's not do that. Let's not waste our time. Okay, next one. Consider this equation. 2x plus 3y equals 4. 4x minus y equals 22. Got my first equation, got my second equation. Okay, well, none of the coefficients are the same. You have 2x and 4x, those are different. You have 3y and negative 1y. Okay, and then constants, no, the constants don't matter. It's the x and y that I need to worry about. Okay, so here's where the process of elimination gets a bit tougher. Okay, and we have to figure out, a little bit different way to solve. So I've got equation 1 and equation 2. Okay, it lays it out for us here. It says, hey, why don't you multiply the second equation by 3? And you think, well, why would I do that? Well, in the first equation, I have 3y. If I had negative 3y, I could add these together and it would cancel out. And you say, okay, well, I'm not allowed to just multiply one piece of an equation by 3, but the rules of algebra say what I do to one side, I do to the other. So if I multiply everything on this side by 3 and everything on this side by 3, and I get my new equations, I haven't changed the equation, I've just changed how it looks. So the first one, 2x plus 3y equals 4, that's the same. But if I tripled that second equation, I now have 12x minus 3y equals 66. This is usually what people forget. If I'm going to triple an equation, make everything 3 times bigger, got to do it to both sides. Okay? So the reason I did this was I want the same coefficient with opposite sign. And I have that. So now I can say, okay, add these equations together. 12 plus 2 is 14x. 3y minus 3y, gone. Don't even write it. Equals 70. Great. Okay. Solve for x. Divide by 14. Divide by 14. X equals, does this work out? 70 divided by 14? 5. Oh, awesome. And I solved. So I did elimination. I just had to do a bit of work first before I had something that would eliminate nicely. Okay. Once I'm here, oh my goodness, I'm running out of space. Okay, I'm going to work backwards. I go into one of the equations, right? Take your value of 5. Maybe you plug it into 1. Maybe you plug it into 2. I'm going to choose 1 because it's smaller. Okay, smaller numbers, smaller coefficients. So I'm going to plug into that one. 2 times 5 plus 3y equals 4. Because I have not a lot of room, I'm just going to quickly do this without showing all my work. Okay, 3y equals negative 6. Y equals negative 2. All right. And could I have verified? Yes, I could have verified, but I didn't want to. So I set up my system. I had to modify one of the equations, make it look convenient. Then I can eliminate. Okay, then I can eliminate. All right. Same question. We're looking at the same system, but we're going to do something a little different. 2x plus 3y equals 4. 4x minus y equals 22. Okay, there's equation 1 and equation 2. Now it says, well, what if you solve it so that you could eliminate x? Okay, what if you solved it so that you could eliminate x? I can totally do that. Okay, what I'm looking for is how could I change one or both of these equations so that I get the same coefficients? And if I'm focusing on x, hey, I could turn 2x into 4x. All I'd have to do is double it, right? Or I could turn, we turned y into 3y. So looking at 2x, I just have to double it, okay? So I'm going to multiply by 2. What I do to one side, I do to the other. And I'm actually going to do something a little different here. So I'll go back and modify that in a sec. But I get 4x plus 6y equals 8. And I didn't change the second equation. That one we're leaving the same this time. Okay, 4x minus y equals 22. So what I've set up is, okay, you've got 4x and 4x. I wouldn't actually add these together, because if I added these equations, I'd end up with 8x. I didn't eliminate anything. I'd have to subtract these equations, okay? I prefer to always set it up so that I add them. And in order to be able to add, I need the same coefficient but opposite sign, where I need this to be a -4. Well, all I'd have to do is, change the sign. You multiply by a negative. So instead of multiplying by 2, if I multiply everything by -2, I get -4x minus 6y equals -8. Okay, so multiplying by the negative sets myself up so that now I can just say, okay, add these together. You get 0x, you get -7y equals, and then you look at -8 plus 22. Well, that would be 14. And it's a quick solve for y. Divide by -7, divide by -7, y equals -2. Hey, that's what we got up above. Okay, we got the same answer. All right. Well, now I'm going to plug that in and I'm going to say, hey, how can I find x? So again, it doesn't matter. Maybe you choose equation 1, maybe you choose equation 2. I plugged into equation 1 when we did this question the first time, just, I don't know, for interest's sake. Let's plug it into equation 2. 4x minus y equals 22. 4x minus -2 equals 22. And I'll go through and solve. Subtract a negative, that's just adding. Subtract 2, 4x equals 20. Do I have room? Yeah, I got a bit of room. Divide by 4, and you get the same answer we got above of x is equal to 5. Okay? Yeah, same answer as above. So, elimination, I have lots of choices. And when my equation doesn't line up right off the bat, I can choose. Can I set this up to eliminate the x's? Can I set this up to eliminate the y's? And then I proceed from there. Okay? All right. 5a plus 3b equals 3. 3a minus 7b equals 81. I look at that one. In terms of coefficients, 5a and 3a are different. So then you think, okay, can I turn the 3 into the 5? Well, no. I'd have to multiply by a decimal. That'd get really awkward. It's not like I'm doubling it or tripling it. I'd have to get something weird. Okay, 3b and -7b. No, the 3 I cannot turn into a 7. So I'm looking at that, and there's no way for me to just change one equation. Okay, I need to eliminate, or I need to change both. I need to change both equations. So here they are. 5a plus 3b equals 3. And 3a minus 7b equals 81. It says it wants us to solve by eliminating b. what I'm going to say is we don't have to. Okay, we don't have to eliminate B. We could eliminate A if we wanted to, but let's just follow along just for interest's sake. Okay, if I am going to eliminate B, I already have the opposite signs. One's positive, one negative. That's nice. But I need to somehow turn a 3 and a 7 into the same thing. I need to find kind of like a common factor. Okay, so what I'm going to say is, I'll just go up to the side. 3, okay, well, 3 times 7 is 21. And 7 times 3 is 21. So it's like finding, I think I said common factor earlier, common denominator. It's like finding a common denominator if I were to add fractions. I am finding what could I multiply so that I actually get the same piece. And in this case, it's multiplying to get 21. So on top, I'm going to multiply by 7. And notice I'm showing the whole thing, just one set of brackets. It's not technically proper notation, but it's fine. On the second one, I'd have to multiply by 3. And my new equations, what I get is 35a plus 21b equals 21. Second equation, I multiplied by 3. I get 9a minus 21b. Hey, that worked. Equals 81 times 3 is 243. 81 times 3. Yeah. Okay. And now it's all set up. Because now if I add these, the 21b and negative 21b cancel out. Okay. I get 44a equals 243 plus 21 is 254. And I'm going to solve. So elimination, this is nice, right? This is a really easy solve for your first variable. A equals, so what was it? Plus 21. Oh, 264. Oops. Okay. Quickly change that. 264 divided by 44. 6. Okay. A value is 6. I found one of my pieces. That's awesome. Okay. Finding the other one, I go back and you say, okay, well, either of these equations is going to tell me the correct answer. I always pick the smallest one or the kind of the easiest to plug into. So I think equation 1 is easier. You could pick equation 2, but that's all right. Which says 5a plus 3b equals 3. So 5 times 6 plus 3 times b equals 3. 30 plus your 3b equals 3. And I'm solving through. Okay, I won't show my work here. 3 minus 30 is negative 27. B equals negative 9. Awesome. I have A, I have B, I have solved my system. It asks us to verify. We're not going to verify just for time's sake. And I have both of my answers. Okay, I totally have both of my answers. All right. It says, hey, think about that system. Could I have eliminated A? Well, yeah. 5a plus 3b equals 3. We're not going to do this entirely, but we might as well take a look at it. 81. Okay. If I'm looking at that thing, okay, I've got my first equation, I've got my second equation. Okay. The 5 and 3, finding a common denominator for 5 and 3, you'd say that's 15. Okay, so the first one, I'd have to multiply by 3. The second one, I'd have to multiply by 5. And then the other thing I'm going to do is I'm going to say, well, right now they're the same sign. They're both positive. I want one of them to be positive 15, one of them to be negative 15. So I'll change the bottom one. And I'll say, okay, let's not just multiply by 5. Let's multiply by negative 5. Giving me 15a plus 9b equals 9. Negative 15a plus, okay, 35b equals negative 81 times 5 is 405. Okay. And now if I look at this, it's set up for me to add, right? I would eliminate the a's, I'd have my b's, I'd have my constant, and I'd solve. So am I going to do this? No. Let's just go dot, dot, dot. Yeah, we could finish it out. Same exact process, just showing It's up to you, right? If there's no obvious one thing could easily be eliminated, if I've got to change both equations, I could eliminate the a or the b, or typically the x or the y. Okay. I think this is the last question. Okay, so let's get one more question and then I'll give you some homework. And you also have a check for understanding today. 4x plus 2y equals 13, or sorry, minus 13 equals 0. 3x equals 5y plus 26. So something to notice, and I wanted to throw this one in to squeeze it into the end of the lesson here. All the other ones we've done today are set up for us. X, y, constant. Okay, x, y equals constant. These are not. So before I get started, I've got equation 1 and I've got equation 2. I'm actually going to rearrange them. Okay, so equation 1 is pretty easy, right? All I had to do was, you got your x, your y. I just need to move this 13 over. So what I do is add 13 to both sides, right? You get 4x plus 2y equals 13. I rearranged it a little. I went plus 13 plus 13. Okay. The other one is a little bit awkward. It's actually the other way. I already have the x on the left side. I need to move the 5y over. So subtract 5y, subtract 5y. 3x minus 5y equals 26. Okay. There we go. I'll write that one down now. There's equation 2. 3x minus 5y equals 26. And now I'm ready to start the elimination process. So one of the things with elimination is we need it lined up before we can even start. But now, okay, now I can absolutely start. Okay, what I'm going to do is, okay, to solve this, 4x and 3x, no, it doesn't line up. 2y, negative 5y, no, it doesn't line up. So I have to pick, do I want to eliminate x? Do I want to eliminate y? I'll pick y because it's already opposite sign. Okay, and then you just have to think between the coefficients, what could I get to a common number or a common denominator? And I think I could get to 10. Multiply the top equation by 5. Multiply the bottom by 2. Okay, so I'm getting 20x plus 10y equals 13 times 5 is 65. Yeah, 65. Okay, 6x minus 10y, there it is, equals 52. And it's all set up for me. If I add this together, the 10y and 10y cancel. 26x equals 65 plus 52, 117. And solving for x is super quick. Divide by 26, divide by 26. X equals 4.5. Okay, so I get a decimal answer. That's okay. Maybe I write it as a fraction. Maybe I just leave it as a decimal. Okay, so from here, it was the same as a normal solve. I just had to rearrange first. And now I proceed like normal. I have your x value. Okay, I have your x value. I got to choose. Do I go back into equation 1? Do I go back into equation 2? Doesn't matter. I'm picking equation 1 again because the numbers are smaller. You could pick equation 2 if you wanted. Right? So 4x plus 2y equals 13. I know x is 4.5. So I'm going to plug it in there and solve. Right? A little bit harder than when I do it in substitution, but that's okay. 4.5 times 4 is 18. Plus 2y equals 13. Is that right? Times 4. Yeah. Okay. And start solving. Subtract the 18. Subtract the 18. 2y equals negative 5. Divide by 2. Divide by 2. Another decimal value. Negative 2.5. All right. And if I wanted to verify, I could absolutely verify, but I'm not going to. Okay, I'm not going to. So there you have it. Another one with elimination. That one was kind of the tougher where I have to multiply both pieces, but ultimately I can still do it. All right. That's enough for me. Here is some homework, 36, 3AC, 4AC, 5B, and 6. And I'll say don't verify if it asks you to verify, okay? You can verify by checking your answers in the workbook, right? Just solve. I want you to focus on solving. I don't want you to waste time verifying. And yeah, that's it for today. That wraps it up for this one. Another one done for us. And now we have all three methods for solving a system: graphically, substitution, and then today we just looked at elimination. So today you got some homework and you have a check for understanding, our last check for understanding of the year. Okay, tomorrow we actually do have a lesson, kind of switching up our schedule. You can see under classwork, I have the schedule for the rest of the year. So we'll have a lesson on Friday, no assignment tomorrow, just the lesson. And then by middle of next week, we'll be wrapping this unit up and wrapping up the year. So as always, ask some questions in the forum, set up a one-on-one appointment, smash the like button, hit subscribe, tune in again for another video tomorrow.